You ever feel like you're just drowning in information? Yeah, we've all been there. Well, today we're going to talk about a simple but honestly genius idea for turning all that data chaos into something clean, powerful, and actually useful. So let's dive right in and see how it works.
It really doesn't matter if we're talking about a room packed with dusty old file cabinets or a single, totally chaotic spreadsheet. The problem is exactly the same. When your information's all over the place, it's pretty much impossible to find what you need. And even if you do find it, can you trust it? It's a universal headache for sure.
So that really gets us to the big question for today. Why is this so hard? I mean, why do our best attempts to keep track of things so often end up as just a tangled mess? Well, it turns out there's a fundamental reason behind it all. And once you get it, the solution becomes incredibly obvious.
To get to that solution, we first have to really understand the problem. So let's meet the villains of our story, the specific things that turn perfectly good data into bad data. Okay, so our first problem has a name: data redundancy. Just take a look at this inventory sheet. You see the item description, bolts 24 millimeters, and its price 29 cents? It's listed right there. Now imagine if we repeated that exact same information for every single order. We'd be storing the same details over and over and over again. It seems harmless at first, but this one little habit, repetition, is the root cause of so many data nightmares.
All right, now let's see why this is so bad. Let's say the company decides to raise the price of those bolts to 32 cents. Well, with our redundant setup, you'd have to go on a treasure hunt, tracking down every single place you wrote down that old price and changing it by hand. And what happens if you miss just one? Well, now your data's inconsistent. You've got two different prices for the exact same item, and you literally can't trust your own records anymore.
And that, right there, brings us to our first official villain. This problem has a name. It's called an update anomaly. That's really just a fancy term for the exact risk we just saw, where one simple update can cause this whole cascade of errors, and suddenly your database is totally unreliable.
But here's the kicker. The update anomaly doesn't travel alone. Data redundancy brings a couple of its nasty friends with it: the insert anomaly and the delete anomaly. They're all symptoms of the exact same disease.
So the insert anomaly, that's when you can't add info about one thing without having info about something else. For instance, you couldn't add a new astrophysics program to your system until a student actually signed up for it. The program just can't exist by itself. And the delete anomaly is the flip side of that coin. If the very last student in Biology 2 drops out and you delete their record, the fact that Biology 2 ever existed could be completely wiped out of your system. Poof, just gone.
So how in the world do we fight these villains? Well, we fight back with one single, incredibly powerful idea. And it's the foundation of pretty much all modern databases. This is the golden rule. It is that simple. Each unique piece of data should be stored in only one place. If you just follow this one principle, those anomalies we were just talking about, they literally can't happen. By making sure every bit of info has one and only one official home, you get rid of redundancy completely. And this picture shows the strategy perfectly. Instead of having one gigantic, messy table that tries to do everything at once, we break it apart. We create a small table just for players, a separate one just for teams, and then a third table that does nothing but connect the two. Now, if a team changes its name, you update it in exactly one spot, the team table. And boom, every player linked to that team is automatically up to date. The villains are toast.
That is an awesome solution, right? But you can't just go splitting up tables willy-nilly. You need a plan. You need a blueprint before you can even think about building.
And that blueprint is called an entity relationship diagram, or an ERD. The best way to think about it is like an architect's plan for a house. It shows you all the main components, all the things you want to keep track of, and exactly how they relate to each other before you write a single line of code.
Making one is actually a pretty logical process. First, you identify your entities. These are just the main nouns in your world, like customers or products. Then, for each of those entities, you list its attributes. The details you need to store, like a customer's name or a product's price. And finally, this is the magic part, you draw the lines that show how they're all connected. You're basically just drawing a map of how things work in the real world.
And here's what you get at the end. This is a finished ERD for a sports shop. Just by looking at it, you can see what's being stored: products, brands, customers, and exactly how they all link up. This isn't just a pretty picture. It's a crystal clear plan for escaping that data chaos we talked about. Okay, so we've got our blueprint. Awesome.
Now we need the tools and the language to actually build the house and bring this whole thing to life. And that is where a language called SQL comes into play.
SQL, it stands for Structured Query Language, is basically the universal language for talking to relational databases. It's really best to think of it like a toolkit, with different types of commands designed for totally different jobs. Now, the two most important dialects you need to know are DDL and DML. And here's an easy way to remember them. Think of DDL, the data definition language, as your construction crew. It uses commands like create table to actually build the structure, the empty shelves and filing cabinets, based on our ERD blueprint. Then you have DML, the data manipulation language. This is your librarian. DML uses commands like insert and select to put the books onto the shelves and to find them again later. So you build with DDL and you manage with DML. Simple as that.
All right, time for the grand finale. We've got our blueprint, we've got our language. Now it's time to do the final, methodical cleanup that guarantees our database design is efficient and, most importantly, free from those villains we met earlier. This whole process, it's called normalization. Let's go back to our inventory sheet. Imagine if, instead of having separate orders, we just tried to cram all the supplier numbers and quantities into a single cell, maybe in a column called order history. You'd have a bunch of values all stuffed into one little box. That is a major red flag. It totally breaks our one piece of data rule and makes it impossible to look at individual orders. A table like that is not in what we call first normal form.
So step one is getting your data into first normal form, or 1NF. This is the first and honestly the most important rule of normalization. Every single cell in your table has to hold one and only one value. Just think of it as the no lists allowed in cells rule. Every little piece of data needs its own personal space.
And here's what that looks like. On the left, you've got that messy idea of one giant sheet. On the right, you see the normalized structure. We've broken it all down into focus tables for inventory, for purchase orders, and for the line items that connect them. This blueprint makes absolutely sure that every single piece of data has one and only one home, which makes it clean, reliable, and way more powerful. Now, normalization actually goes a bit deeper with more steps to clean up even trickier issues. But you know what? It all boils down to one simple goal. Every table has a unique identifier, right? We call that a primary key, like an item number or an order ID. And the big idea, the mantra you gotta remember, is that every other piece of data in that table must depend on the key, the whole key, and nothing but the key. If you can stick to that, you guarantee every table is laser-focused on just one topic and is as efficient as it can possibly be.
So, we've gone from a total chaotic mess to a beautifully structured blueprint, and we've learned the rules to keep it all clean. This kind of brings us to a final thought. Now that you can spot redundancy and the villains that it creates, what messy data in your own work, or your hobbies, or even your life is just sitting there waiting for a little bit of normalization?